and function names. We're also going to understand function overload and pointer functions. And we are also going to learn user-defined functions, how users create their own defined functions. Functions in C++ are a block of codes designed to perform specific tasks. They are fundamental for organizing code, promoting reusability, and making programs easier to manage. And the types of functions we have are the user-defined functions and the standard library functions. The user-defined functions are created by programmers to perform specific tasks for them. And also the standard library functions. They are predefined functions that are available in the C++ libraries, such as the std, where we get the cout, and std, where we get the square root function. And so another type of function is the virtual functions and the inline functions. Basically, virtual functions in base classes that there are functions in base classes that can be overridden in derived classes, enabling polymorphism. And also inline functions, they are functions where the compiler replaces the function call with the function's code, potentially improving performance for small functions. Now, benefits of functions: there is modularity, which is the breakdown. It breaks down complex programs into smaller, manageable units. So it's like a whole program will break into smaller parts that is performing different tasks each. And reusability, it can be reused without you writing all that block of code under it. So write code once and use it multiple times. Basically, that's the reusability. And also abstraction, is hide implementation details and focusing on whether the function does rather than how it does it. Improve readability, it makes code easier to understand and maintain because you understand it once and for all. You don't have to repeat it in your code. And this is how we declare function, also known as function prototype. It declares the function's name, return the type and parameters before the function is defined. It allows the compiler to verify correct function calls. And this is how it begins: the return type, the function name, and the parameters. Basically, just like this, we are using this int as a return type. It should return an integer for us, and we are using this our per the syntax. This our function name, and this our parameters. We are giving it a first parameter. We are creating a first variable with the int data type, and this one will be the second number with the int data type. And when we are calling it, we call like this. We look further that. And function definition is a function declaration in which the body of the function is presented. The structure. A function definition includes a return type, the name, and a parameter list, which is optional. And the body enclosed in curly braces, just like this. So our return type, our function name, and now parameters. And with this, you include whatever you want the function to do. This is the function body and the statement to perform a task. And this is the return value, and it's optional too. So the keywords you are supposed to note is the return type. It specifies the data type of the value of the function will return. Use void if the function does not return a value. So if you don't want it to return maybe integer or something, you just use void. And the function name, an identifier that uniquely names the function. So this is actually your function name. That's the function name. You can name it any name you want, but sure, for per naming variables it should be reasonable and readable. So the parameters, they are the input values that are passed to the function. They are declared with their data types, with their types and their names. And the function body contains the code that executes when the function is called. So basically the function body is actually what is inside the function, what when you call the function, what it's supposed to do. That's actually the function body. And a return statement is used to send back a value back to the caller. So if return type is not void, it will return it back to you. So let's say you specified it as int, it should return back the integer value for you. That's why the return statement is there. And so here I'm looking at a simple function with the int variable name. This is the int data type, and this is the function name, and these are the parameters passed on it, and this is the function body. As usual, we are saying our integer result should be the first name plus the second name. Basically that's addition. So after it does it should return this data type out, the results for us. So you can call this anywhere and it will function. The parameters are variables in the function definition that receive the argument. So here like this, you see this and this, they are the variables here, and they receive the argument when you call it. We'll look at how to call it. So here's syntax, the return type, your function name, and your type name, your other type, and the name as you go on. Then the argument, the actual values passed to a function when it's called. So let's say this is my function name and this is it. Let's take for instance this function. To call it, you have to use the add and open bracket and give it a number here, comma, another number, just like this. And it is going to get inserted here. These variables will store them. The arguments are what you call, the arguments here are the 1 and 2 we are going to insert. And these people are the parameters. The first name and the second name, they are parameters that are going to receive those numbers. They are like the variables, and they will be used in the calculations. We have other arguments. We have the references, we have the pointers, and we have the arrays. And the fourth argument, the actual values assigned to parameters during function definition or declaration. So the syntax is return type as usual, the function name, your type and your name, and the other type and the name, and you use equal to the value. This when you want to give it a constant value or something. Yeah, so just like this. So anywhere you call the function, you give it this, and to add this to it, like how this one is, we are supposed to return the summation of x and the value of y. So just like this basically holding the default argument. So function calling, to execute a function, you call it by its name followed by parentheses and any required argument. So the syntax is the function name, your argument one and your second argument. So far as you use two parameters. So like the add we used, our first variable be here. We can give it 1 or 2 or any number we wanted because it was just summing two numbers. And we give it the second number. We make sure we separate them with a comma, and always remember the end of line character. We are also going to look at function overloading, and it's defining multiple functions with the same name but different parameters. It is used in cases where there is a need for one function name but differences in parameters. A function in C++ can be overloaded in three different ways, and this by having different numbers of parameters, by having different type of parameters, and by having both different number and different parameters. So let's see here. We have the integer. We are declaring a function called add with the integer data type, and you are giving it parameters int a and int b. And this basically what it is doing. It will return the summation of a and b for us. And also we are declaring another function with the same data type and the same name but different number of parameters, and this is going to return the different number of parameters, the summation of them. You can see the difference between them. Yes, so this is how you can declare your function, and this is another way you can declare function, and this is the case 1. The case 2 here is we have this as usual, and this you can see there's a different data type here called a double for the same function name, and it has different variable name data types for the variables, but it has the same parameters also but different data types. And this is the case 3. We're also maintaining this, and we have a double as of our data type for our function.